Hello and welcome back to the channel. In the previous video, we looked at methods in depth, and in this video, we're going to be looking at arrays and array lists. When we want to store a collection of related data types, we use arrays. So arrays are a collection of values of the same type, and to access elements of an array, we use the element's index. An index is a number that starts from 0 and goes up to the end of our array. Now, since indexes starts from 0, the first element in our array is going to be located at index 0. Now, to see arrays, we're going to create a new class. We're going to call it SumArray. And since we're going to be running this program, we're going to tick public static void main, and we're going to press on finish. Creating an array is similar to creating an object. So the first thing we're going to have is the data type of our collection. In our case, we're going to use int. Then to differentiate arrays from other data types, we're going to have square brackets. Then we're going to give our array a name. In our case, we're simply going to call it array. And we're going to have an equal sign, and we're going to have the new keyword, followed by the data type again. And in square brackets, we provide the number of elements we want to store in our collection. So we can have 10 here. So this is going to be an array of integers that is going to store 10 values. To insert in elements, we're going to have the name of the array. And in square brackets, we're going to give the index where we want to store our data. So if we want to store it at the first position, we're going to have 0. And we're going to have an equal sign, and we're going to give it an integer value, for example, 12. So this is one way of declaring an array and adding in elements. So we're going to comment this out, and we're going to see the second method. So if we already know the elements that we want to store in our array beforehand, we can use a different syntax. So we're going to have the data type, which is going to be integer, and we're going to call it array. And we're going to have an equal sign, and we're going to have curly braces. And inside these curly braces, we're going to put in the elements that we want to store in our array. Now, the program that we're going to be building is going to calculate the total or the sum of the elements inside our array. So we're going to have a total variable, and we're going to initialize it to 0. Now, to go through our element, we're going to use a for loop. Our initializing statement is going to be int I is equal to 0. This is because indexes start from 0, and our condition is going to be while I is less than array dot length. So as we said, arrays are like objects, and like objects, they have different attributes and methods that we can access. So in this case, we're accessing the length attribute, which is going to give us the length of our array. And since we're going to be starting from 0, we're not going to include the array length in our condition. So we're going to have less than instead of less than or equal to. And finally, our updating statement is going to be I++. Now, inside our for loop, we're going to have total plus equals array, and in square brackets, we're going to give it I. So what's going to happen here is in the first iteration, it's going to access the first element of array, and it's going to add it to our total. It's going to do this until it gets to the end of our array, and it's going to add it to the total. Finally, we can print out our total using system.out.printf. Our format is going to be total of array elements %d, new line, and in the %d, we're going to substitute total. Now, if we save our file and run our code, we get the total of array elements is 849. Now, it's okay to use this type of for loop to access the elements of our array, but there is a special type of for loop that we can use, which is called an enhanced for loop. So we're going to have for, and in parentheses, we're going to have a temporary variable that is going to store the elements of our array. And after a colon, we're going to have the name of our array. And inside the for loop, we can have total plus equals element. So this element variable is going to store each element in our array. So in the first iteration, it's going to have 87. In the second iteration, it's going to have 68, and it's going to go on until the end of our array. So now if we save our file and run the code, we get the same output. The arrays we've seen so far are one-dimensional arrays, but in Java we can also have multi-dimensional arrays. For example, if we wanted to represent a table or a matrix in our code, we would use a 2D array. So to see this, we're going to create a new class, and we're going to call it 2D array. And since we're going to be running this program, we're going to tick public static void main, and we're going to press on finish. So the syntax to declaring a 2D array is similar to a 1D array. We're going to have the data type. Then instead of having one set of square brackets, we're going to have two sets of square brackets. Then we're going to give our 2D array a name. We're going to call it array, and we're going to set it equal to new int. And in square brackets, we're going to define the number of rows and the number of columns we want. So for example, if we had 3 and 4, this means that our 2D array is going to have 3 rows and 4 columns. And in total, it's going to be able to store 12 elements. And again, to access the elements, we're going to use indexes. So when we use 0, 0, we're going to the first row and the first column. And to give it a value, we're going to have the same statement as before. So we're going to have an equal sign, and we're going to give it a value. Just like 1D arrays, we can also define 2D arrays using a different syntax. So if we already know the elements that we're going to store in the 2D array, we're going to have int, then a set of 2 square brackets, then the array name, then we're going to have an equal sign, and we're going to have curly braces inside curly braces. So inside the curly brace, we can have 87, 68, 94. So this is going to represent one row. So we can have another set of curly braces, and we can define other elements in the second row. And finally, we're going to add one more row. Again, this program is going to calculate the total of the elements in our array. So we're going to have int total, and we're going to set it equal to 0. To access every element of the array, again, we're going to use a for loop. So we're going to have for, and our initializing condition is going to be int row is equal to 0. And our condition is going to be row less than array.length. And we're going to update our row variable. So this is going to go through the number of rows. So here array.length is going to be 3, since we have 3 rows. And once we have access to the rows, we need to access each element in each column. And to do that, we're going to need another for loop. So we're going to have another for loop. The initializing statement is going to be int column in is equal to 0. And our condition this time is going to be call is less than array at row dot length. And we're going to update the call variable. So what's happening here is array at row is going to give us an individual row. So in this case, if we get the first row, we're going to get a length of 3. If we get the second row, we're going to get a length of 3. And for the final row, we're going to get a length of 4. Now we can go inside our nested for loop, and we're going to access array at index row and at index column. So this is going to give us each element in our 2D array. And once we have the element, we're going to add it to our total. And finally, outside the for loops, we're going to display our total variable. So we're going to have system.out.printf total, and we're going to have %d, and we're going to substitute the total variable. Now if we save our file and run our code, we get the total, which is 849. Now to make the concepts of arrays more clear, we're going to implement arrays into our gradebook class and add some more functionalities. In our gradebook class, we're going to remove the determine class average method, and we're going to define a new instance variable, which is going to have an access modifier of private, and its type is going to be int, and a set of 2 square brackets. So it's going to be a 2D array, and we're going to call it grades. And in our constructor, we're going to have an input, an additional input, which is going to be int square brackets, and we're going to call it grades array. And we're going to set our grades instance variable to the grades array that gets inputted when we create an object. Next, we're going to go to the end of our class and we're going to define a new method. It's going to be a public method, and its return type is going to be void, and it's going to be called process grades. And inside this method, we're going to call another method called output grades, which we have not defined yet, but we're going to define. And we're also going to have a print statement, which is going to print out the lowest grade. So we're going to have %d and the highest grade. And we're going to have another %d followed by a new line character. And inside the first %d, we're going to call another method, which we have not defined yet, which is getMinimum. And in the second %d, we're going to have getMaximum, which we also have not defined yet. So the first method we're going to define is the getMinimum method. So it's going to be public, its return type is going to be int, and it's going to be called getMinimum. And it's not going to take any input. So inside this method, we're going to calculate the minimum grade. To do that, we're going to first declare a variable called lowest grade, and we're going to set it equal to the first grade we have. Now to access the first grade we have, we're going to use grades at index 0 and at index 0. So this is going to give us the first grade. Now, once we've set the lowest grade, we're going to go through the remaining grades, and if we get a grade that is lower than our lowest grade, we're going to update the lowest grade variable. So to access each element of our 2D array, we're going to use for loops. Another concept we didn't see in the previous file is that we can use enhanced for loops for 2D arrays as well. So we're going to have for. So our temporary variable is going to be a 1D array, and we're going to call it student grades, and we're going to access the grades 2D array. And inside this for loop, we're going to have another for loop, and our temporary variable is going to be int grade, and we're going to be accessing the student grades. So what's happening here is student grades is going to represent one row, and int grade is going to represent each individual grade inside our student grades array. Inside our nested for loop, we're going to have an if statement, and the condition is if the grade we're looking at currently is less than our lowest grade, then we're going to update our lowest grade variable to the current grade. And finally, outside our nested for loop, we're going to return lowest grade. The next method we're going to define is the getMaximum method. So it's going to be public, its return type is going to be int, and its name is getMaximum, and it's not going to take in any input. Similar to the getMinimum method, we're going to have an int called highest grade, and we're going to initially set it to the first grade we have. And we're going to have our nested for loop, which is similar to the one we had previously. So we're going to have student grades, and we're going to access the grades 2D array, and we're going to have another for loop, and we're going to have int grade, and we're going to access student grades. And inside the nested for loop, we're going to have an if condition, and we're going to check if the current grade we have is greater than our highest grade. And if it is, we're going to update our highest grade to be equal to the current grade. And finally, outside of our for loops, we're going to return highest grade. Next, we're going to define a method that's going to calculate the average for a set of grades. So it's going to be public, it's going to return a double, and it's going to be called getAverage. And it's going to take in a 1D array as input, and we're going to call it set of grades. So it's going to calculate the average of a set of grades. First, we're going to need a total variable, which is going to be initialized to 0. And we're going to go through the set of grades array. So we're going to have int grade, and we're going to access the set of grades array, and we're going to add each grade to the total. And finally, we're going to return our total divided by the number of grades we have, which we can get using set of grades dot length. Now, since we want a double to be returned, we can cast the total to be a double. Finally, we're going to define our output grades method, which is going to be public. It's going to have a return type of void, and it's going to be called output grades. And it's not going to take in any input. First, we're going to print out the grades are followed by a new line character, and we're going to end our statement. And next, we're going to have a printf statement. And the format we're going to have is a bit more complicated than the ones we've seen before. We're going to have %10s, %10s, another %10s, another %10s, and one more %10s. So we've seen numbers between the percent and the placeholder. So we've seen it before when we were dealing with the precision of decimal values. We had 0.2. And when we have a whole number between the percent and the placeholder, it's going to define our column width. So what that means is each placeholder is going to take up 10 spaces. So we're going to have a uniform spacing. And the first %s, we're going to simply have a space. And the second %s, we're going to have test1. And the third %s, we're going to have test2. And the fourth %s, we're going to have test3. And finally, in the fifth %s, we're going to have average. And we're going to end our statement. Next, we're going to display the grades of each individual student. To do that, we're going to have a for loop. So we're going to have for int student is equal to 0. And our condition is going to be student is less than grades.length. And we're going to update our student variable. Now, there is a reason we used the traditional for loop. That is because we want to use the student variable to represent each student. So we're going to have a print statement. And our format is going to be student followed by %2d. So in the place of d, we're going to substitute the student variable, the one we have in our for loop, plus 1. So what this means is it's going to display student1, student2, student3, and it's going to go on until the last student. Once we've displayed the student, next we're going to display the grade. To do that, we're going to have another for loop, and this time we're going to use the enhanced for loop. We're going to have int test, and we're going to access grades at the index student. So what this means is grades is a 2D array, and when we access grades at a specific index, we're getting a 1D array. So we're going to be accessing each element of that 1D array. And we're going to have a printf statement. And our format is going to be %10d. And we're going to substitute in test. So again, %10d means that our placeholder is going to take up 10 spaces. And finally, we need to display the average. So we're going to have double average, and we're going to set it to a call to the getAverage method. And we're going to pass it a 1D array. So if you remember, our getAverage method took in a 1D array and calculated the average of that array. So we're going to give it grades at index student. And finally, we're going to print out the average. So we're going to have %10f, and we're going to substitute in average. Now if we go back to the top of our code, our errors should disappear. Here we're getting an error, that is because we misplaced the semicolon. So now we're going to save our file, and we're going to go to the gradebook test class, and we're going to remove everything we have in our main method. First, let's create a 2D array that stores 3 test results for different students. So we're going to have int, 2 sets of square brackets, and we're going to have grades array, and I'm going to fill out the elements of this array. Once we filled out our 2D array, we're going to create an object of type gradebook, and we're going to call it my gradebook, and we're going to set it equal to new gradebook. And now our constructor takes in 2 inputs. The first is the name of the course, which we can give Introduction to Java. And the second input is our 2D array. So we're going to give it grades array. And next we're going to access different methods using the myGradebook object. So we're going to access display message, and we're also going to access process grades. Before we run our code, there are a couple of statements we need to fix in the gradebook class. So we're going to go back to our gradebook, and inside our output grades method, we're going to add a new line before the student number. This is going to allow each student to occupy a single line. And one more new line character we need to add is when we display the lowest and the highest grade. So we can save this file, go back to our gradebook test, and now if we run our file, so first we get the course title, then we have each test result for each student and their corresponding average, and at the end we have the lowest grade and the highest grade. The next concept we're going to be looking at is array methods. So the array class provides different static methods that we can use to manipulate our arrays. To see this, we're going to create a new class, and we're going to call it array manipulation. And since we're going to be running this class, we're going to tick public static void main, and we're going to press on finish. In order to use the different static methods, we need to import the array class. So we're going to import it now. We're going to have import java.util.arrays. Now, since we're going to be using static methods, we don't need to create an object using the arrays class. So to see the different methods, we're going to define a double array, and we're going to call it double array, and we're going to give it a set of elements. So the first static method we're going to look at is sort. So to access the sort method, we're going to have the name of the class, which is arrays. Then we're going to have dot. Then we're going to put in the method name, which is sort. So sort takes in a parameter, and this parameter is going to be an array that is going to be sorted. So we're going to pass in double array. So now to see that the sorting has been applied, we're going to use an enhanced for loop to print out the different elements. So now if we save our file and run our code, we get the different elements in sorted order. Another static method we can look at is the fill method. To see this, we're going to create an int array, and we're going to call it filled int array. And we're going to set it equal to new int, and we're going to give it a certain size. We're going to give it 10. So we've not defined any elements in our array. So in order to fill our array, we can use arrays.fill, and it's going to take in 2 parameters. The first is going to be the array that is going to be filled. So it's going to be filled int array. And the second argument is with what value we want to fill our array. For example, we can pass in 7. So what this method is going to do is it's going to add 7 to each index of our array. To see this, we're going to print out the different elements. So now if we save our file and run our code, we can see that 7 has been added to each index of our array. The last topic we're going to be looking at in this section is going to be array lists. The main difference between an ordinary array and an array list is that an array list is dynamic. This means that we can change its size at execution time, which we cannot do with ordinary arrays. And there are different methods that come built in with ArrayLists, like the add method to add elements, the size method to return the number of elements, the get method to obtain an element at a specific index, the remove method to delete a specific element, and the contains method to check if an item is in an array list. So to look at array lists, we're going to create a new class. And we're going to call it ArrayList collection. And since we're going to be running this program, we're going to tick public static void main, and we're going to press on finish. In order to use an array list, we're going to have to import it. So we're going to have import java.util.ArrayList. And to create an array list, it's going to be similar to creating an object. We're going to have ArrayList. And in angled brackets, we're going to have the data type. So in our case, let's say we want the data type to be string. And we're going to call this list item. And we're going to set it equal to new array list. And we're going to have an empty set of angled brackets followed by parentheses. So this is going to create an array list of type string. So to add elements to the list, we're going to have the name of the list followed by the add method, and we can give it a string. So it's going to add the string red to our list. Another way we can use the add method is by providing an index. So we can have add 0, yellow. So what this is going to do is it's going to add the string yellow at index 0. And for example's sake, we're going to add more items. Now to see the different elements, we're going to use a for loop. So we're going to have for int I is equal to 0, I is less than item dot size. So here we're going to use the size method for array lists instead of length, and we're going to increment I. And inside our for loop, we're going to have a print statement. And we're going to print out each string. So we're going to have %s followed by a space. Now to get an element at an index from a list, we're going to use the get method, and we're going to pass in I as the index. So now if we save our file and run our code, we get the different elements in our array list. Another method we can look at is the remove method. So in our case, we have 2 yellows in our list. But if we had item.remove and in parentheses, if we gave it yellow, and now if we saved our file and ran our code, as you can see, the first yellow gets removed. So that is how the remove method works. It's going to delete the first occurrence of whatever value you give it. So it's going to remove the first yellow. The final method we're going to look at is the contains method. So we're going to have a print statement. And we're going to say is red in the list. And we're going to have a Boolean value. The placeholder for a Boolean value is %b. And in %b, we're going to substitute item.contains the string red. So if we save our file and run our code, we see that is red in the list is evaluated to true. That is because red is in our list. If we had an element that is not in our list, for example, purple, and if we saved our file and ran our code, we would get false. Before we end this section, one more thing to note here is, let's say you wanted to create an array list of type integer. You cannot simply pass in int for the data type. You're going to get an error. What you need to do is use the object version of int, which is integer with a capital I. So that is how you would create an array list from primitive data types. So that's it for this section. In the next video, we're going to be looking at classes and objects in more depth. Thank you for watching this video, and don't forget to like the video and subscribe to our channel for more programming content.